Hi guys, this is my review for chapter 4, the physical properties of water. Um, Again, I'm sorry, but as a biology student, I've gone through all of my chemistries, and biology is really close to chem too. So a lot of this chapter was review for me, but there were some things I did learn and found very interesting. Right off the bat, they said how water used to be considered a pure element, which just makes me laugh. Um, oh, this is funny. They reviewed the temperature scales, how we have Celsius, Kelvin, and Fahrenheit. I use Kelvin a lot in chemistry, but I thought the most interesting thing was that they said the United States is one of the only countries that uses the Fahrenheit scale. They did a lot of review. Well, some definitions. Dew point is the temperature of water vapor saturation. So is when water vapor condenses into a liquid. They reviewed latent heat of fusion, which is the heat necessary to change a water state from solid to a liquid. And then latent heat of evaporation is the heat required to change the state of water between liquid to vapor. And they talked about sublimation, which was something that I found interesting and a question I tie in. So sublimation is when ice turns directly into gas under very dry and cold conditions. So that's very interesting to me because I just don't see how they could completely skip liquid. So my question is the liquid state included at all in sublimation, even if it's for a split second? I can't believe that it completely skips a liquid state. Um, let's see. They reviewed a lot of energy transmission. They talked about conduction, convection, and radiation. Again, this is review, but I liked how they stated how conduction. Conduction is a molecular process. Convection is density-driven process, and radiation is like the direct transmission of energy of heat between different energy sources. They reviewed a lot about surface tension, which some things that I learned about that was how closely it's related to cohesion, and which is why if you pass or if you fill a glass of water past the brim, it won't overflow, and why insects can walk on water and everything like that. The most interesting thing that I learned about surface tension, surface tension is that surface tension is related to the formation of waves. Completely did not know that. They reviewed Behr's law, and they connected that to MOBI, which the marine optical buoy. But they but they go on to say how that technology helps satellites look for it improves satellites, but these satellites are actually looking for different coloration of the ocean surfaces, which is very interesting to me that they're actually looking for phytoplankton to see if our oceans are being biologically productive. I just didn't know that they use phytoplankton for something of such importance, and how phytoplankton shows so much about our oceans. They talked about how whales and porpoises use the echo sonar. I knew whales, I feel like everyone does, but I did not know porpoises also used it, and that's how they can judge what direction the reflections come from, and so they know which way to go. Oh, I'm sorry, I skipped something else that I learned. The transmission of heat energy is actually the same between salt water and pure water, and that was just something that I learned because I would figure they would be different because salt water and pure water have different compositions. So I don't know. It just surprised me that they were the same. Some things that I found interesting. I talked about sublimation. I knew this. OChem drills this into your mind, but I knew that water has a bent shape. But I liked how the text said that because of the shape, that's why it requires more energy. Just a nice little review. Forget about these things. they talk about he, they talked about how heat is measured in calories, which made me laugh because I used to do labs in like basic chem or possibly even maybe bio in high school, but we used to light Cheetos on fire to find out how many calories were in one Cheeto, which was funny. And so they go on to break it down to say that 1 calorie is the amount of heat needed to raise 1 gram of water by 1 degree Celsius. Fun fact. They talk about how water bonds only last a few trillionths of a second. That was something I did not know. Relating back to OChem, they talk about the electromagnetic spectrum, and they break it down and tell you the range of nanometers for visible light and how red light has longer wavelengths than blue, for example, which are shorter. But then they tie it into the ocean, saying that the red wavelengths can only penetrate about 10 meters into the ocean, and that the shorter the wavelength, the farther it can reach. Which ties in a question of mine. How accurate are echo charts when detecting seafloor materials? I know that they said that there's little air and how the bending and fracking happens with sound measurements because of, but and I know that they said because of the beam that they shoot into the water is perpendicular to the water layers, that there's little air, but it's just hard for me to believe that they can tell so much about the seafloor without actually like experiencing it through that. So my question is really how accurate or how little air is there. So some questions that I had where I talked about how accurate, just elimination. Okay, so my third question is going back to the echo sonar with whales and porpoises and whatnot. Is there any technology that humans can use? So say you get in an accident and you become blind or develop some disease or whatnot. Is there technology that you can use that almost mimics that sonar? I know if you were born blind or became blind at a young age, that people develop that skill. But right off the bat, say you become blind, is there anything that you can do that would be that helpful without having to slowly learn that skill? Some things I would like to learn more about. It stated how the government and navies do a lot of underwater sound studies. I would like to learn more about that and what actually they're doing. I would like to learn with global warming or just climate change, how much does it affect the salinity of the oceans, like pH and whatnot, and like how does that relate to the effect of the animals that live in the ocean? I mean, you can put changing pH, I understand, but with such a mass amount of water, does it really have an effect or not? I guess is my question. And my last, or something I'd like to learn more about. And the last one I have for that is the deep scattering layer. And they can tell small animals like fish and how they move and whatnot. I guess my question is, what studies do they use that for? I know like fishermen probably use that technology, but do biologists use it to track migration patterns or whatnot of small fish? Because you can't really tag one individual like they do with mammals, like dolphins and whatnot. Like they get tagged, but do they do the same with fish? And is that something that they use? I don't know. I would like to know. I would like to learn. Okay. I hope you guys let me know if you have any questions or can answer my questions. I would appreciate that. Oh, wait.